Welcome to This Explainer. Look, if you're a developer, a data scientist, or honestly just an engineer who loves quantifying your life, you are exactly where you need to be. Today we're unpacking a really exciting prospect, natively bridging real-time health data with developer workflows. We're going to be unboxing a brand new open-source CLI, a command line interface that completely flips how we interact with the Google Health API.
But before we get into the weeds, just think about this for a second. How exactly do you pipe your own heartbeat into an AI agent? I mean, think about the usual friction, right? Wrestling with OAuth 2.0 flows, digging through those deeply nested, messy, raw APIs, and writing just endless boilerplate code only to parse a single timestamp. Well, what if we could strip all of that friction away? How do we get clean, usable health data straight into a large language model's context window? Well, let's dive into exactly how we can do that.
So here's our roadmap for the explainer today. First, we'll meet the ghealth CLI, then check out the 40 types of health data it handles, walk through setup and authentication, explore its agent-first design, look at some real-world use cases, and finally, see how it compares to other options out there.
All right, Section 1. Meet the ghealth CLI, the single Go binary. So let's meet ghealth. This is an open-source CLI that basically acts as a super clean wrapper over the Google Health API v4. And what makes this so elegant is its architecture. It is built entirely from source using just a simple go build command, and it ships as one self-contained single Go binary under the Apache 2.0 license, which means absolutely no messy dependency trees to manage on your local machine. It's just one file, ready to go.
Now, what's actually really interesting here is where this tool lives. ghealth is the official successor targeting the Google Health API v4, which, by the way, replaces the legacy Fitbit Web API. But the crucial part? This CLI lives right inside the Google Health API GitHub organization. That is the exact same org hosting the long-standing Fitbit open-source repos. So, for any data scientist or engineer looking to wire this into a pipeline, that location instantly adds some serious credibility.
Moving on to Section 2, 40 types of health data, or what we call the surface area.
40. Yeah, that is the sheer scale of the data we're dealing with here. The tool exposes 40 verified data types, and they're all immediately available as cleanly structured JSON.
Those 40 types pretty much cover anything you'd ever want to track. You've got your standard signals, steps, heart rate, sleep, but then it gets into advanced clinical-grade types like oxygen saturation, heart rate variability, and even ECGs, though those do require specific read-only scopes. It even supports writable types, so you can create, update, or delete entries for things like exercise or body weight. But the operation that is an absolute game-changer here is called reconcile. Say you've got a Pixel Watch and maybe a connected third-party source, right? You're going to get overlapping data points. The reconcile operation smartly merges those overlaps, mirroring the reconciled stream in the v4 API. To really illustrate the power of the CLI's built-in flags, just take sleep data, for example. If you run a default list command, you just get a basic, high-level summary of your night. Simple enough. But simply add a -- detail flag, and boom, that basic summary transforms into a rich, stage-by-stage breakdown. It shows exactly when you were awake, when you hit deep sleep, and your REM cycles. It's exactly the kind of granularity you need if you're trying to spot real physiological patterns week over week.
All right, Section 3, Setup and Authentication, Secure and Local.
Let's tackle the elephant in the room for any developer handling PII. How on earth do we securely authenticate highly sensitive health data? The answer here is a really brilliant bring-your-own-credentials approach. If you have ever pulled your hair out wrestling with OAuth boilerplate, you are going to love this. You just start by creating a desktop-type OAuth client in the Google Cloud Console. Then, you run a super simple command, git health setup. A built-in wizard literally walks you through the rest. The tool holds absolutely no shared key. It relies on a highly secure, headless PKCE flow with an S256 challenge, validating a random state parameter the second it completes. Best of all, your tokens are written locally to your machine with strict 0600 file permissions, and they just auto-refresh in the background. Now, it is important to note that all Google Health scopes are classified as restricted. What does that mean? Well, if you want to build a full production app for other users, you'll have to go through a rigorous privacy and security review from Google. But for personal use, you can instantly authorize your own GCP project against your own Google account and just start hacking on your own data right away. No waiting around.
Section 4, the agent-first design. Clean JSON out.
So everything we've talked about sounds awesome for a human sitting at a terminal, right? But here is the kicker.
ghealth was explicitly built from the ground up for AI agents. It uses deterministic exit codes, meaning an agent knows immediately and exactly if a command succeeded or failed. It packs --dry run and --raw flags for safe, predictable exploration. And even better, the repository ships with 2 agent skills written right into ski.md files. One handles global flags and setup, and the other documents all 40 data types and patterns. An agent can pull this context directly using npx skills add, literally teaching your AI how to use the CLI in seconds.
Just think about the raw Google Health v4 API response for a moment. It is deeply nested, incredibly complex, and honestly, it wastes precious LLM tokens. But with ghealth, by default, every single command returns simplified JSON with a highly stable shape, grouping rows neatly under a data points array. It's essentially the perfect format to be piped straight into an LLM's context window, without confusing the model.
Which brings us to Section 5, Real-World Use Cases, the test drive.
So what can we actually build with this data pipeline right now? Well, let's look at 3 really powerful workflows. First up, AI agents. You could pull, say, several nights of sleep data using the detail flag, and then pipe that JSON directly into Claude Code or a Codex session. You can just ask the agent to summarize your deep sleep trends over the past week. Second, data science. You can effortlessly export workout tracks straight into pandas for some deep geographic or biometric analysis. And third, dashboards. Query your daily resting heart rate over a 30-day window, output it as a CSV, and immediately chart the whole thing in a Jupyter notebook. It's that seamless.
Speaking of data science, there's a concrete command line argument that seamlessly extracts an entire workout, grabbing all the GPS track points and the perfectly matched heart rate data, and it exports the whole shebang directly into a flat CSV format. So no manual JSON parsing required whatsoever. Just clean data ready to go.
And for those of you pulling massive, multi-year datasets, rest assured, pagination is handled flawlessly. Large lists return a next page token. You simply pass that right back to the CLI with the --page token flag, guaranteeing completely lossless data extraction for your models.
Finally, Section 6, how it compares the verdict. Let's objectively look at where ghealth sits within the broader ecosystem of API wrappers, because it's all about trade-offs. If you call the Google Health API v4 directly via REST or gRPC, sure, you get maximum raw control, but you also have to handle all the OAuth 2.0 and JSON parsing boilerplate yourself. Not fun. There are a few other options out there, like an unofficial Node.js npm CLI, but that requires a full Node environment, and it's totally unaffiliated with Google. ghealth, on the other hand, it gives you a lightweight single-go binary, secure PKCE off, and agent-ready simplified outputs. And it does all of this while being officially hosted right inside the Google Health API community organization.
Which brings us to the final verdict. Listen, if you are building a massive enterprise-scale consumer-facing application, the direct REST API is always going to be your ground truth. But if you are building for the terminal, if you're doing local data science, or especially if you're engineering agentic AI workflows, ghealth is a massive time saver that drastically cuts down your authentication and formatting boilerplate.
We've unboxed the architecture, explored the 40 data types, and seen the agent-first design that makes this tool so uniquely powerful. The friction between your wearable device and your AI's context window, it's basically gone. So the only real question left to ask is, what is your health data going to tell your AI? Go grab your own wearable data, fire up your terminal, and start building. Thanks for joining this explainer.